future cities could be 3D printed using concrete made with recycled gas. This is by Seder Gaffar, Senior Professor, Civil Engineering, Environmental Materials, Brunel University, Mehdi Kugan, Marie Shlodowska-Curie Research Fellow, Brunel University, London, Powell Sikora, Associate Professor of Civil and Environmental Engineering, University of Technology in Szczecin. On the conversation, 3D printing concrete may lead to a shift in architecture and construction because it can be used to produce new shapes and forms that current technologies struggle with. It may change the century-old processes and procedures that are still used to construct buildings, resulting in lower cost and saving time as well. However, concrete has a significant environmental impact. Vast quantities of natural sand are currently used to meet the world's insatiable appetite for concrete at a great cost to the environment. In general, the construction industry struggles with sustainability. It creates around 35% of all landfill waste globally. Our new research suggests a way to curb this impact. We have trialed using recycled gas and a component of concrete for 3D printing. Concrete is made of a mix of cement, water, and aggregates such as sand. We trialed replacing up to 100% of the aggregate in the mix with glass. Simply put, glass is produced from sand, is easy to recycle, and can be used to make concrete without any complex processing. Demand from the construction industry could also help ensure glass is recycled. In 2018, in the US, only a quarter of the glass was recycled, with more than half going to landfill. So building better, we used brown soda lime beverage glasses obtained from local recycling company. The glass bottles were first crushed using a crushing machine, and then the crushed pieces were washed, drilled, milled, and sheaved. The resulting particles were smaller than a millimeter square. The crushed glass was then used to make concrete in the same way that sand would be used. We used this concrete to 3D print wall elements and prefabricated building blocks that could be fitted together to make a whole building. If used in this way, waste glass can find a new life as part of the construction material. The presence of glass does not only solve the presence and the problem of waste, but also contributes to the development of a concrete with superior properties than the containing natural sand. The thermal conductivity of soda lime glass, the most common type of glass which you find in windows and bottles, is more than 3 times lower than that of quartz aggregate, which is used extensively in concrete. This means that concrete containing recycled gas has better insulation properties. They could sustainably decrease the cost required for cooling or heating during summer or winter. Just remember, fiberglass has glass in it. Now, improving sustainability, we also made other changes to the concrete mixture in order to make it more sustainable as a building material, including replacing some of the Portland cement with limestone powder. Portland cement is a key component of concrete used to bind the other ingredients together into a mix that will harden. However, the production of ordinary Portland cement leads to the release of significant amount of carbon dioxide as well as other greenhouse gases. The cement production industry accounts for around 8% of all carbon emissions in the environment. So that's about 10%. Can you imagine? Limestone is less hazardous and has less environmental impact during its production process than Portland cement. It can be used instead of ordinary Portland cement in concrete for 3D printing without a reduction in the quality of the printing mixture. We also added lightweight fillers made from tiny hollow thermoplastic spheres to reduce the density of the concrete. This changed the thermal conductivity of the concrete, reducing it up by 40% when compared with other concrete used for 3D printing. This further improved the insulation properties of the concrete and reduced the amount of raw materials required. So using 3D printing technology, we can simply develop a wall structure on a computer, convert it to a simple code, and send it to a 3D printer to be constructed. 3D printers can operate for 24 hours a day, decrease the amount of waste produced, as well as increase the safety of construction workers. Our research shows that an ultra-lightweight, well-insulated 3D building is possible, something that could be a vital step in our mission towards net zero. This is on the conversation. I think this is fantastic. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.